So in this video, I want to talk about how we can actually automate the TCE verification for binary signing and like checking if the binary signature is like valid and like all good. Basically the signing, notarization, and things like that. So TCE, we get Tanzu CLI, we get the TCE plugins, we get the Tanzu framework plugins and whatnot. So there's a lot of plugins which are all binaries, and then there's also the Tanzu CLI, which is a binary. So these are all signed. So how we would actually go about like checking if they are signed properly. So currently, what we do is we have this pipeline. Moment. So let me share my screen and show this pipeline. So currently we have this pipeline which checks. So there is this thing called release gate, which is basically checking, or which is kind of like a gate for your release. So if this gate stops you, it means like there's a problem with the release, something like that. So in this case, it's checking if the Mac OS and Linux OS release builds are all good, and then if the Windows OS release build is good. And when we check for Mac OS release build, what we do is, so if you notice here, it says Mac OS and Linux OS, and it says it was run manually by TC automation. There was some automation, and this is, so one of them is Mac OS. So this is Mac OS, and this is for the Ubuntu Linux one. So in Mac OS, if you notice what we do over here is that we get this. So we get a tarball, and basically we download a particular version of TC, and then we install TC. So basically we untar or like extract the tarball and then install TC. And then once we do that, actually we don't even have to install, sorry. We could, but we don't install TC, but instead we just open it up and then get all the binaries in it and start checking out if the binaries are like, signed properly. So in this case, you can see this tool being used called SVCTL and verbosity and then type install. So it's a binary of type install, or there's other things like executable and things like that. So, and then assess and things like that. And then so here we are assessing this, and you can see this here. Next one, we are assessing, say, we are assessing the cluster plugin, which is the workload cluster plugin for Darwin. So this is all like macOS, so it will say Darwin. So we get into each directory and then check it out, and it says clearly that it's accepted, notarized developer ID application is VMware incorporated and things like that. So we do this everywhere, and then finally we also install it. So once we check that this is all good, we install it. We do the installation later because if you try to install before even checking if the binaries are properly signed, the problem is that let's say you are on macOS and one binary is not signed properly with a valid private key, let's say. And what happens, the code signing didn't happen for that binary properly. What happens is that when you install it, what Tanzu, this installation does is basically moves the binaries, and it also invokes those binaries to check the, say, version or something like that. And anytime you invoke a binary that's not properly signed on macOS, macOS will open up a pop-up saying, hey, this is not from a verified developer, and it will cause errors. It will say, move this binary to the bin, trash bin. And so yeah, you will have problems during the installation, the pop-ups coming up when the binary is not properly signed. So that's why we first check if it is all properly signed, and then we go ahead with the installation. And finally, after installing, we also check the versions. So basically, we invoke the plugins by calling the plugin commands. The tricky thing with this is this was all done in a very hard-coded manner. So if you look at the workflow file for this, you can see this thing called release check release build .sh. So this is inside this release build test. So check release build sh, and there is also a PowerShell one, which is for the Mac, Windows. So the shell file is for both macOS and Linux. And you can see the help and things like that. So you can see how we use SPCTL and then like check it out. check out each and every plugin, and then check out the Tanzu CLI, and then type every plugin, and also we type Tanzu version. So this we have to keep changing when there is a difference in plugins. Like let's say I'm testing out TCE, then I'll have to put TCE plugins and Tanzu framework plugins. Let's say I test out a different edition, let's say downstream. This is open source, so current edition is upstream and it's open source, so I can test it like this. Let's say I'm testing out TKG standard edition or advanced edition with a different set of plugins. I'll have to rewrite this part. Instead, there was one idea by David Wonson that, why can't we just look at the list of plugins inside the tarball, or even something like in Tanzu after installation, it actually has a list of plugins or the metadata about the plugins and everything inside a file. So why can't we use that and then pick up from that and then get the names and then iterate over that and then call version, and then that's all. So then it will become dynamic. Then it might just work for any version. So any TC version, even Tanzu framework, it'll just work. You just have to install Tanzu framework, and same thing for the binaries, right? As long as you're able to find all the binaries and then call SPCTL on it, you're good. And we don't have to call SPCTL for Linux. So in this case, we clearly say that only if this is Darwin we do this, checking off the signature, so signing. But for Linux, we do everything else. Of course, we check if the plugin works, we can install it, and the plugin gets invoked. And so that was for like Mac OS and Linux. There is also one for Windows. So we do something similar, but just in Windows. So in Windows, instead of SPCTL, we have this thing called, there's a tool called Sign tool, which we use. So here you can actually see the workflow, and the Sign tool is basically present. One moment. Oh, no, this. Just a moment. Workflow for this Mac OS Linux. Okay, this is Mac OS Linux. Sorry, this should have been okay. I'm have to look at the Windows one. This is the one. No, this is sorry. So the Windows one is actually over here. Sorry, Windows one is a totally separate pipeline. And if I look at the workflow file, so here you can see this sign tool path, which I actually mentioned it as a parameter name. The path for this sign tool is inside this thing called Windows Kit, Windows 10. This the version of GitHub runner that we use has Windows 10, so we are using that and using this sign tool. And here, what we do with that is we check if the signature is right. We say sign tool path, basically the sign tool, and then verify, and then verify the the binary. And finally, we also install. And after installing, we also check if the like Tanzu version, this command works, and then all the plugins get invoked and they work. Actually, this can be done in a different manner. For example, we can write this piece of code. We can unite this using Golang. And of course, even if you use Golang, we'll still have to use the sign tool or SPCTL depending on the platform you're running on. And Linux, we don't need to do that. And when we run it, there are two things we're looking at, right? So one is we are checking if the signing and notarization is all good, like if the binary signature is good. So that is one thing. For that to happen, you need to know all the binaries that are there in your software. So in this case, the Tanzu CLI and all the plugin binaries. So there must be some program to tell you, hey, given this program or given this thing, this is the list of binaries that you need to verify. And then there is another program that takes each and every binary, iterates through the binaries, and then uses the platform specific thing to actually check if the binary is good and like is signed properly. So on Linux, we don't have to do it. On Windows, it's a sign tool. And then on Mac OS, it's SPCTL or something similar to that. And then once you do this, the final step is basically you install TC or you install your program, and then you check if the program runs. So in this case, we simply run the version commands to see if the version command of the plugins work, of Tanzu CLI works, to see if the binary is like the integrity of the binary is not a problem, like it's not corrupted. If it's corrupted or if there's some issue, then it wouldn't run. So we simply invoke the version command alone. Of course, this is not a full-blown test, but this is simply to check the sanity of the binary to see it's in a good shape and it's not corrupted. So the binary build is good and like it's signed and the version command works, so it is probably not that bad. If some other feature doesn't work, it's probably a more like a code level issue and not some build issue. So that's a good idea of how we can actually merge these two scripts, the PowerShell script and the shell script, and not maintain these two separate scripts doing the same thing mostly, except for the sign rule parts calling verify, but the behind the scenes logic is the same. You get your list of binaries. That is one thing. You check the signature of the binaries depending on the platform, platform specific tool, and on Linux you don't even have to do it. And then you install and then check basic sanity of the binaries. And the other thing is to do this three-step process, we can actually have three separate tools instead of writing this down in one tool, or at least three separate components, which can become their own binaries. For example, we can have one binary to which gets the list of Tanzu CLI, Tanzu plugin binaries and whatnot, and gives out the list. Let's say in a JSON or whatever, like any programmatic manner, YAML, JSON, whatever. And then there is another tool that picks up any binary that you give to it. And then depending on the platform, it will actually check if the binary has a good signature. So this can take up the output of the first program, let's say JSON, and then pick up that. The JSON can say something like the path of the binaries, the name of the binary, the path of the binary, maybe that's all. And with the path of the binary, you go find the binary and then check if the signature is good. And then the next thing you can do is basically, that's a separate tool which can actually just install and then run the program. So three separate tools. What this will help in is, let's say you test out, and this generic tooling will help you reuse this tool anywhere. Like I can reuse the tool and say, I can have one more tool which finds out the binaries for Tanzu framework. And I can have one more tool or one more thing to find out the binaries of say TKG standard edition. And then that will just pass it to the same old tool that does simply just knows, hey, I know this is a binary in this path. Now I can just check if the code signature is good or not. That's all I need to do. I don't need to know if this is coming from TCE or Tanzu framework or whatever, right? And then there's a separate tool which understands what is the program and then how to install it and then how to invoke it and then check if it is if the binaries are same, like all the it's not corrupt and things like that. Yeah, that's all I wanted to talk about in this video, and I will see you in the next one. Bye bye.